Identity-based access for Azure Files allows administrators to manage permissions using existing credentials rather than static keys. This helps create a more secure, streamlined method of accessing data and aligns with enterprise identity management practices. By integrating Azure Files with Azure Active Directory, Azure AD, users benefit from single sign-on experiences and unified credentials. It also enforces organizational policies on file shares without relying solely on shared access signatures or static keys. This approach builds on previously covered topics, such as configuring storage firewalls and virtual networks and managing access via SAS tokens. In this module, we explore the prerequisites for identity-based authentication, clarify how Azure Files relies on domain-related settings, and outline the different integration paths. We also examine scenarios where hybrid setups can adapt on-premises Active Directory to provide a unified experience. Through these configurations, organizations can maintain consistent permission models, auditing, and compliance, thereby mitigating security risks. When configuring Azure Files for identity-based access, administrators have two primary integration routes: native Azure Active Directory integration or Azure Active Directory Domain Services, Azure ADDS. Native integration leverages Kerberos authentication over SMB, enabling seamless credential usage if the environment is fully cloud-based. On the other hand, Azure ADDS supports more traditional, domain-joined architectures, allowing existing on-premises identities to map to Azure Files permissions. These options ensure that organizations can choose the alignment that best suits their hybrid or cloud-native deployments. In prior modules, we discussed controlling network traffic with firewalls and using SAS tokens for granular file access. These remain relevant, but identity-based methods add an additional layer by enforcing user-specific constraints. This modular approach supports enterprises at various stages of cloud adoption. Understanding each integration option's structured requirements, configuration paths, and potential impact on existing workloads is essential before deciding which route offers the most benefits in your infrastructure. Before implementing identity-based access for Azure Files, several prerequisites must be satisfied. First, your subscription should be linked to Azure Active Directory, and the Azure storage account used must be upgraded to a secure protocol version, namely SMB 3.0 or higher. If using Azure ADDS, ensure synchronization from the on-premises Active Directory or a fully functional cloud domain environment. Additionally, verify that your storage account supports the identity-based authentication feature and is configured for the appropriate performance tier, standard or premium, as it can impact cost and throughput. Depending on your chosen approach, you may require Azure AD Connect to facilitate identity synchronization. Permissions in Azure AD for creating or modifying enterprise applications may also be necessary to establish the relationship between Azure Files and domain services. By confirming these prerequisites, you minimize potential configuration errors and ensure that your environment is ready for advanced identity-based access scenarios. Azure Files supports multiple permission models. On Windows servers, NTFS permissions govern file-level access, while Azure Files extends the native NTFS permissions to the cloud environment. Administrators can combine Azure RBAC roles with NTFS ACLs to fine-tune user access. When domain-joined machines access Azure File shares over SMB, file and folder permissions can be validated using Kerberos. This approach seamlessly mirrors standard Windows file server behavior. However, it is crucial to distinguish between storage account permissions and ACLs applied within the file share. Storage account permissions govern major administrative actions like file share creation or key management, whereas NTFS-style ACLs govern read, modify, or write privileges within the file share. By integrating both layers, organizations can achieve a granular access model consistent with on-premises behavior. Understanding how these permissions intersect ensures that administrators can maintain robust security boundaries and appropriate user access levels for different workloads. Azure Role-Based Access Control, RBAC, provides a powerful mechanism to govern resource-level permissions, surfacing distinct roles tailored to storage usage. Common roles include the storage account contributor, which allows creating and managing file shares, and the storage file data SMB share contributor, which enables modifications inside shares. Assigning these roles at a resource group or subscription level cascades privileges down to relevant storage accounts and file shares. To configure identity-based access, administrators can allocate roles to specific Azure AD users or groups, linking them to the exact level of control required. This approach helps avoid over-provisioning rights, since a granular assignment ensures only necessary tasks can be performed. Once users are authenticated using Kerberos, these roles effectively combine with file-level ACLs. In tandem, they deliver a comprehensive access strategy that merges high-level resource management with detailed file access control. Consequently, organizations gain clarity and consistency in user rights management. Azure AD Domain Services, Azure ADDS, enables domain join capabilities without deploying and managing domain controllers in the cloud. This service simplifies the extension of on-premises identity infrastructure to Azure, syncing user authentication and group objects automatically. When combined with Azure Files, Azure ADDS allows users to leverage domain credentials to access file shares over SMB. For organizations that rely on-premises AD-based authentication, this approach preserves existing processes. Setup involves creating the Azure ADDS instance, enabling synchronization if needed, and then configuring the file share to use domain-based authentication. To ensure proper security, administrators should also integrate group policy objects to enforce password policies, multi-factor authentication, or conditional access at the domain level. This domain-first approach often appeals to organizations that require full compatibility with traditional applications while benefiting from the elasticity of Azure-based file shares. Organizations with hybrid solutions, spanning on-premises and cloud environments, frequently leverage Active Directory Federation or Azure AD Connect to synchronize identities. For Azure Files, a hybrid configuration might entail mapping on-premises domain accounts to Azure AD user objects. One can configure Kerberos-based authentication for SMB access, ensuring file shares in Azure remain accessible to on-premises Windows servers seamlessly. During setup, it is critical to ensure that DNS resolution is correctly established for the domain services, allowing the resolution of Azure domain controllers. In some cases, trust relationships need to be configured between the on-premises Forest and Azure ADDS. Additionally, care must be taken to maintain consistent user principal names, UPNs, across the environment. By achieving these integrations, users experience single sign-on when accessing Azure file shares, preserving the same file-level permissions and Windows ACL structures that exist on-premises. Implementing identity-based access for Azure Files requires careful attention to best practices. Assign roles at the lowest practical level, such as a resource group, rather than broad subscription-wide roles, to maintain least privilege principles. Combine Azure RBAC with Windows ACLs for a layered approach. Use RBAC to control high-level tasks like share creation and ACLs to restrict file-level read, write, or delete actions. Keep synchronization from on-premises directories to Azure AD updated to avoid orphaned or outdated accounts. Enforce multi-factor authentication or conditional access policies for users with elevated privileges. Whenever possible, run routine audits on assigned roles and permissions in Azure to detect anomalies or excessive privileges. Logging and monitoring features, including Azure Monitor and Azure Storage Analytics, can provide insights into potential access issues. By adhering to these guidelines, administrators heighten security while preserving user-friendliness. In more complex setups, you may encounter issues such as Kerberos service ticket failures, DNS resolution conflicts, or misaligned user principal names resulting from hybrid identity synchronization. When diagnosing problems, verify correct DNS server settings and confirm that the storage account is domain joined with the proper security identifiers, SIDs, mapped. Additionally, Confirm that your SMB protocol versions match the requirements for Azure Files identity-based authentication, namely SMB 3.0 or higher. Log auditing can reveal both successful and failed authentications, which aids in pinpointing user permissions misconfigurations. Complement these logs with Azure AD Connect Health to identify synchronization irregularities between the on-premises environment and Azure AD. It is also advisable to confirm that relevant ports are open in any network security group or firewall used in your environment. These advanced considerations ensure that your identity-based configuration remains stable, even as organizational requirements evolve. Ongoing monitoring of Azure Files is vital to proactively identify unauthorized access attempts and performance bottlenecks. Azure Monitor provides metrics for file capacity, transaction counts, and throughput. By creating custom alerts, administrators can receive notifications for excessive read or write operations. Audit logs, available through Azure Storage or Azure AD, capture essential details about authentication attempts and changes to role assignments. Pairing logs with external tools or Azure Sentinel can yield deeper insights, correlating file share access with other security events in the environment. Additionally, you can enable diagnostic settings for storage accounts to collect metrics on SMB requests. These logs help isolate issues such as repeated failed login attempts or abnormal data transfer spikes. Keeping a structured approach to auditing bolsters compliance and fosters transparency, providing data that can be essential when defending against security breaches or meeting regulatory requirements. Configuring identity-based access for Azure Files can be automated using PowerShell scripts. Start by installing the required AZ PowerShell modules, ensuring they are updated. Use the new AZ storage account command to create or update storage accounts with the Active Directory domain services for a file parameter. Next, join the storage account to the domain by specifying the domain GUID and the domain's NetBIOS name. Once the domain join is successful, use Set AZ Storage File Share to enable Azure AD-based permissions for a specific file share. Optionally, you can set granular ACLs by leveraging the Windows-based PowerShell command setACL, although you must appropriately map the SID from Azure AD or Azure ADDS. Validate authentication by mounting the file share on a domain join machine and verifying user-level read and write permissions. This script-based workflow allows organizations to standardize deployments across multiple environments, ensuring consistent settings and reducing the potential for human error during manual configuration. Azure Resource Manager, ARM, templates offer declarative configurations for identity-based access to Azure Files. Within a JSON template, specify the storage account properties to include Active Directory domain join parameters, such as domain name, NetBIOS name, and organizational unit path. This approach supports infrastructure as code principles, ensuring repeatable deployments in development, production, or test environments. After the template is deployed, your storage account is domain joined automatically if all prerequisites, like networking and DNS, are in place. Additionally, you can incorporate a nested template or script extension to configure specific file shares for Azure AD authentication. By storing revised ARM templates in a version control system such as Git, you gain traceability and rollback capabilities for changes in domain configurations. This means that any environment can be recreated or updated with minimal manual intervention, aligning with best practices around DevOps and cloud infrastructure management. When enabling identity-based access for Azure Files, it is crucial to account for several security considerations. First, ensure data encryption is enforced at rest and in transit, typically accomplished by default for Azure Files, which uses server-side encryption and SMB 3.0 encryption. Monitor privileged accounts carefully, since domain administrators or storage account owners can override file permissions. Employ logging and alerting mechanisms so that suspicious activity, like large data extractions or unusual login attempts, is detected promptly. Consider conditional access policies in Azure AD to enforce location and device-based restrictions, thereby safeguarding sensitive file shares. Implement just-in-time access or privileged identity management to reduce attack exposure. Lastly, confirm that any supporting systems, including DNS servers and domain controllers, are patched and follow principle of least privilege guidelines. By focusing on these elements, organizations maintain robust data protection while taking full advantage of the functionality offered by Azure Files in a cloud or hybrid environment.